Hello, physical sciences students, grade 10, 11, and 12. This video can be beneficial for all three grades. Now, the first thing we're going to learn today is this table. You have to know this table, right? We have here current, and the symbol of current is I. We also have charge. The symbol of charge is Q. And then we have time. The symbol of time is T. Voltage. The symbol of voltage is V, and we have energy. The symbol of energy is W. Then we have resistance. The symbol of resistance is R. And here we have units, which means how they are measured. So current is measured in amps, charge is measured in coulombs, and then time is measured in seconds. So whenever you have time, you have to convert it to seconds. So when this voltage is measured at V. Voltage is also the potential difference. So when you're asked to calculate the potential difference, you are asked to calculate the voltage. So energy is measured in joules and resistance in ohms. So here they are when they are written there, those units, how these different things are measured. Now we have this triangles. You have to know this triangles. That energy is calculated by timing voltage and charge. That's how you get your energy. And then your charge, you get it by multiplying your current and your time, right? And then your voltage, you get it by multiplying your current and your resistance. So in grade 11, this is a triangle that is most commonly used, but in grade 11 and grade 12. But for grade 10, all these three are used all the time. But in grade 11, this is the most popular circle, the triangle that you have to know, right? So when you want I here, you'll say V over R. And when you're looking for R, you'll say V over I, right? Voltage over current for you to get resistant. And when you want current, you will say voltage over resistant. But when you want voltage, you will say current times resistance, right? So here I have just written them down for you as well, how to get voltage, current, resistance, and energy using this triangles. This is how I have simplified it here. So voltage is the potential difference, right? It gives resistance some push. So let's say this is voltage and this is resistant. It's pushing the resistant, and whatever that comes out from that push will be what we call current, right? Current is the flow of electrons, which are these electrons. These electrons is voltage and resistance. So current is the flow of voltage and resistance. So when there's low resistance, there's high current. There is nothing stopping the voltage from going through, right? So the resistance is very low, so there will be high current. And when there is high resistance, there will be low current. All right, so we're going to talk about a resistor, right? So in a circuit, we have different resistors. We can have a resistor, the resistors that are in series, which is what you see here. These ones are in series. Or we can have the ones that are in parallel. Now, what really is a resistor? A resistor is a passive electrical component with two terminals that limits the current flowing in electrical or electronic circuits. So it limits the current flowing, right? We say it's voltage, then meets a resistor. But when that voltage is able to penetrate through the resistor and go to the other side, that will be current flow, right? Its property to resist the flow of current is called resistance. Expressed in ohms, Resistors are used for various purposes such as reducing current flow, adjusting signal levels, dividing voltage, and terminating transmission lines. So that's what it is, right? So when the resistor is low, like 2, there will be a lot of current flowing there, unlike this. So this makes it hard for current to flow. It's very high, right? So here, but the same amount of electricity will flow because they are in series. So when we talk about resistors in series, are the resistors that are on the same line going where current is not divided. So current is just flowing from this resistor, it will go and it will come across this resistor, it will go and come across this and resistor here. So how to calculate total resistance in a series? We say R1 plus R2 plus R3. So this will be, let's say this is our, let's say this is our R1, this will be our R2, and this will be our R3. But they're just going straight. It's just that I had made a mistake there of starting with 3 and not starting with 2. But let's, for this example's sake, let's just leave it like that. So this is how we're going to get our total resistance when the resistance is in series. So these resistors are voltage dividers. They divide the voltage that is flowing in that point. So we are going to say 3 plus 2 plus 9, and that is 14. So 14 is our total resistance in this circuit where the resistance is in series. Now, yes, so remember, series is when a daisy chain, like series, resistors are connected in a series when they are daisy chained together in a single line. Just to see here, this is a single line. The same current flows through all the resistors. So the current that flows here flows also here and flows also there as well. The total voltage across all the resistors is equal to the sum of the voltage across the resistor. So that's what you have to remember. So meaning that if any resistor is broken, if this one is broken, or a fault or case, or if this one is broken, the entire circuit will be turned off. All right, now this is a resistor in parallel. Potential difference is the same across all resistors, meaning voltage is the same across all resistance. Voltage is the potential difference. Now we will do it. Don't worry. Resistors are in parallel when they are connected between the same two nodes. This means that the voltage is the same across all resistors, but the current is branched out and recombined. So let's say this current is starting maybe here, or let's just make another one here, but we can just leave it here. When the current gets here, it will be splitted. Other current will go this side, another amount of current will go this side, and another amount of current will go this side, and they will all flow. This one will flow going here, this one will flow going here, and they will all meet here. So the voltage is the same across all three resistors. So they're in parallel. When we try to find the total resistance of resistors in parallel, we'll say 1 over Rp equal 1 over R1 plus 1 over R2 plus 1 over R3. We still take these R's like the way I've shown you. It's just that you just say them over 1. So R1 is 6, that's 1 over 6. R2 is 3, 1 over 3. R3 3 is 1, then that is 1 over 1. And when you put that in a calculator, you will get 3 over 2. But what we are looking for is the resistance. So we will just take what is in the bottom to the top and what is in the top to the bottom, and then we just measured it in ohms, just like that. So this is how we calculate the total resistance in a circuit. All right, now here we are, right? In series, current is higher than in parallel, right? Because in parallel, the current that is flowing needs to be split. When the current gets at this point, another amount of current goes this side, another side of current goes this side. They go like that and they come and meet here, and they'll be the same, right? So you have an ammeter. An ammeter is a device used to measure the current in a circuit, right? Current needs to be measured. The current that is flowing, how much electricity is flowing within that circuit, we use an ammeter to measure that. So what is being recorded on the ammeter here, this is the ammeter, it's 6 amps. So this 6 amps has to be distributed between this row and this line, right? Because when it gets here, it will split into 2. Now we have to know how much amps are flowing here and how much amps are also flowing in this direction. So what to do is you can use a ratio, right? 5:10. You can divide that by 5 to simplify it. That is 1, and this is 2. So we have simplified that ratio. So you're going to say the total 1 plus 2 is equals to 3, right? So you are gonna say 1 over 3 times 6 to see what flows up there. That will be 1 over 3 times 6, and 2 amps will flow here. And then you will say 2 over 3 times 6, 2 over 3 times 6, and that is 4. So 4 amps will flow here and 2 amps will flow here, and they will both meet here. And then in this line you will also have 6 amps as your ammeter if another ammeter is placed here. Okay, now we have this circuit here. Electricity in a circuit flows from this bigger one. You must look at this is the battery. Look at this. This is the bigger one. It's positive. So electricity will flow not from this side. This is a negative. The small one is negative. So always when you're presented with a question, electricity question, for you to know which direction does the electricity flow, look at this bigger one. It's positive, so it will flow, go like this, go this way. This is not parallel, this is voltage, it's not resistor, so it will go like this. When it gets here, these are 2 resistors, right? So the other amount of electricity will flow go in this direction, the other one will flow going this direction, and they will meet here. If we have an ammeter here, the reading on this ammeter will be the same as this one and as this one here, if maybe we have 3, or as another one here, because there's no parallel here, right? So that's what is going to happen. The current is only shared in parallel. So what we are going to look at here is this. This is the voltage, right? This V1 is the total voltage. So there can be voltage flowing here. We can measure the amount of voltage on this resistor, and we can also know the amount of voltage on these 2 resistors here. So in order for you to get the amount of voltage on 4 here, this one this is the total voltage. So this voltage here and this one's here, because these ones are the same, but you don't add them, but they are the same. If it's 6 here, it's 6 here, and let's say here is 6 as well to make it 12. So that's gonna be, we're gonna take this one plus this one, it will has to be equal to this. But if they were in series, if there was another one, just like I had previously shown you, if we are here, the voltage here plus the voltage here plus the voltage here needs to make that 12. The voltage, the total voltage in the battery. So this small resistance voltage has to make that one. But with this one's in parallel, just one, the resistor is the same, but you do not add it. So with this one, the voltage in the battery, maybe let's say this here, the voltage here it's 12. The voltage here will be 12 across all of them, and the total one will also be 12 on the battery. Yes, so voltage is the difference in electric potential energy between 2 points, which is defined as the work needed per unit of charge to move a test charge between the 2 points. It is measured in volts. Voltage can be caused by various mechanisms such as static, electric fields, electromagnetic induction, or election flow. It is also the pressure that pushes charged electrons through a conducting loop, enabling them to work. Voltage can be calculated using Ohm's law, which states that voltage equals resistance times current. So that's like we have seen, voltage equals resistance times current, as we have seen previously. So let's say we want total voltage, right? When we want total voltage, we are gonna make use of this. This is total voltage, right? So when we want total voltage, we are gonna take current times resistor, right? I have shown you how to calculate resistor. You will calculate resistor for this one, which is still 4, right? And then this 2 will be calculated in this manner. 1 over Rp equals to 1 over R1 plus 1 over R2. And that will be, all right, and that will be 1 over 3 plus 1 over 6. And that will be 1 over 3 plus 1 over 6. That's 1 over 2. So remember, when you get to the answer, you say Rp, that will be 2 over 1. The answer first will be 1 over 2. And then when we get here, we'll change this answer to 2 over 1. This is what we're looking for. The one that is in the bottom is exactly, the one that is in the bottom is what we are looking for. Here, Rp equals to 1 over 2. So this is what we have. We have this 1 over 2 plus this 4. And then we will have 9 over 2 as total resistance, right? It's for the whole circuit. Now we have total resistance. We also have voltage. So we have here, we have calculated the potential difference, which is the total resistance. This is what we have here. Now what we were trying to calculate is that when we want this voltage in the main circuit, we use this one. That will be our total resistance, and then we'll use this current here. The current flowing here, it's 2 amps. So it will just be this times that 2, right? So let's say, but that's not what the question wanted us to calculate, because we have been given the voltage. So I just wanted to show you that this voltage here, how to get this voltage in here. So when you want this voltage, you are still going to say resistor times A. So you're just going to calculate between these small ones. So you will say 2 times 4, that is 8, and that is the voltage that flows in this 8 volts in this resistor. And then when you say 12 minus 8, you will get 4, right? Which means there's 4 volts here and there's 4 volts here. But this 4 plus this gives you 12. So that's just what I'm trying to show you with this reading on the ammeter. So this times this equals this, right? So this times this 3 will give you this. So for you to get this voltage here, you still do the very same thing. You still say this ammeter times resistance. If you want this one they didn't give you, you are going to calculate all of this resistance and then times by the ammeter, and then it gives you the voltage. I hope you understand all that I am trying to enlighten you on regarding electrical circuit. All right, so another thing is internal resistance, right? Is the ability of an object to hinder the flow of electrons passing through a conductor. It usually refers to the electrical resistance inside batteries and power supplies that can limit the potential difference that can be supplied to an external load. So internal resistance is measured in ohms. It is caused by heat loss, friction, and other processes which act to slow down or stop the movement, right? So we have in grade 11 and grade 12, you now have to know internal resistors. You have to know how to calculate them, and we use the MEF, maximum energy provided by the battery per coulomb unit charged passing through it. So the EMF here, we have the total current. This will be the internal resistor, which is the lost voltage. And here we will have this is the it is the EMF. It's measured in joules. Even if you have work, when they say like work or energy, this is the energy. So we are looking for the energy. When we're using the EMF, we're looking for energy when the switch is open, right? When the switch of the current is flowing, there is no current flowing in the current. When the switch of the current is flowing, no, it's not that. I think it's when this I didn't write it properly there. Yes, I didn't write it properly. It has to be when the switch of the current is open, there is no current flowing in the circuit. So we are looking for the energy. So this, remember, as you have previously seen, the symbol I is the current, stands for current. So this is total current. So when you have the energy and you are looking for current, and you have internal resistor and the total current, you can do this. The external, not the external current, the external, sorry, this was supposed to be this one. This arrow was supposed to be here on this eye. This is the total current. Then this one is the external resistor when the switch is closed and the current is flowing. And this is the internal resistor. So this is the external resistor, this is the internal resistor, this is the total current, and this is the energy. So when you're looking for this and you have energy, you can also use this formula for grade 11s and grade 12s to find your or you have an internal resistor but you don't have your external resistor. This is not for grade 10. Yes, let's meet on our next video where I will be going deeper into this topic. Don't forget to like, comment, and subscribe. It helps the channel. Thank you very much for watching, guys. Until the next one. Bye.